Over to you.
Hey everyone, I'm Jeremy Varner and I'm the chair of the Local Involvement Committee. And it's my privilege and honor today to introduce Dr. Bob Bachus as the next cross-country lecturer for the Geo-Institute. Dr. Bachus got his bachelor's and master's degrees from the University of Illinois Chicago Circle and his PhD from Stanford. He's a registered professional engineer in several states, Georgia, Mississippi, Kentucky, Alabama, Arkansas, Pennsylvania, Tennessee, and North Carolina. He was on faculty at Georgia Tech from 1979 to 1990, or full-time. He remains an adjunct professor. And since 1990, he has been working for Geotech out of their Atlanta office, working in a wide variety of geotechnical and waste management practices. He has over 40 years of experience. Anything you can think about in geotechnical engineering, Bob's done it, but especially in waste management and dam safety, seismic design. I first got to meet, not first, but one of my first real interactions with Dr. Bachus was at the end of my master's degree at Georgia Tech. I needed a class to fill up my schedule, and I just picked a landfill design class. I had no interest in landfills, or at least I didn't think I had interest in landfills. It seemed very environmental, and I wasn't going that way. But I needed a schedule to fill up, and I signed up for this landfill design class. It was co-taught by Dr. Burns and Dr. Bachus, and I'm so lucky that I signed up for that class. I learned a lot. It was one of those experiences where even though the topic might not be what you need, the professor definitely is. Dr. Bachus was, of all the professors I had, he was the most excited and it's clear that he very much enjoyed teaching and just practicing and just being in the world of engineering. And I got to see that outside the classroom firsthand a few years after graduation. I was able to be on the same gear field team with Dr. Bachus for the field reconnaissance regarding flooding and some dam failures due to Hurricane Joaquin in 2015. And we spent a couple days going around Columbia, South Carolina, looking at several failed dams. And the interesting part to me is I was out there with my field camera. You know, it's waterproof, GPS compatible, does all sorts of fancy things. And Dr. Bachus had a spiral bound notebook and a big pen, and just interesting working with him because I was trying to take the right picture, but we just there figure out, and I learned a lot from that because as many times as I want to take the right picture, forcing yourself to draw a sketch forces you to focus on the important details and make sure you capture those details while in the field, and that was a really good experience. So without further ado, I'll turn it over to Dr. Bachus, and to everyone listening, you're in for a real treat. Make sure you stick around for the whole show.
Thank you very much, Jeremy. And I'm going to see if this works now according to, let's see, Darren, we go share screen, and I share that screen. And are we good to go, Aaron? So you can see the full screen now. Okay, perfect. Well, good afternoon, everybody, and thank you very much for the introduction, Jeremy. The topic today hopefully will be a timely topic for you. I'll give you a brief introduction as a follow-up. Again, I want to express my appreciation to Brad and the Geo-Institute for this. To the next hour, we're going to be talking about geotechnical data and what do we do with that, and hopefully can leave you with a few takeaway messages. One of the notions about this was that, as Brad said, I had delivered a number of presentations over the course of the last few months around the country, and in March that ground to a halt because of this coronavirus. So just from a health and safety perspective, just want to remind everybody that, with the uptick that we're seeing, to always remember we have the social distancing and all that. But more importantly, I think now, as this has drug on, just remember that sheltering doesn't mean isolation. And a lot of people, I think if I look over the last few months, what I miss most is seeing my friends and colleagues every day. And, that includes your family, extended family, your parents. And, let's not forget that. But I think the other thing that we're learning is that this idea of Zoom meetings, WebEx meetings, YouTube, I think is going to become our new norm. And we're going to have to adapt to that. So in thinking about the virus, though, I pulled a couple of images relative to virus. And the one thing you'll note with this is that there's this little schematic up here. And at the bottom of it, it says about this data. So the only way that we can get information about the virus and communicate it is to share data. And if we had, as we do with the virus, if we had these data, we could develop graphs and tables that are updated essentially automatically. And we can develop little maps that show hotspots around the country. So even with this very brief introduction, it's all driven by data. So just to have that seed as a plant. As Brad said, the across USA, the one word that Brad did not choose to use was that the Geo-Institute recognizes that the geotechnical profession is in fact a prestigious organization. And we want that particularly to be sent to our students, because I think everybody on the call who is a non-student recognizes that today's students are going to be the standard bearers in the future. And so anything that we can do to get them excited about what is really an exciting profession is great. As Brad said, I am the ninth, I think it's been 10 years, but this is the ninth presenter of the Cross USA, my predecessors. I am very honored and humbled to be added to this list of the folks that are listed here. They have been friends and colleagues and in many cases mentors of mine in the past. And I really do appreciate that opportunity. Since we're talking about data and we're talking about the Geo-Institute, I thought another good way of introducing this is that for the GI members, if you look at the current version, the current issue of GeoStrata, which comes out 6 times a year, this is called Future Geo. And if you look at the table of contents, you'll find that for these 6 topics, they are all driven by data. So the future of geotechnical engineering is in fact going to be cognizant of big data. And we need to be aware of that. So if you don't have an opportunity, you can read this online. The articles are really very, very well done and would be well worth your time to look at this. I'm going to focus on one of those, and that is the article that was written by Scott Anderson. And if for those that know Scott, he was with Federal Highway before he joined a consulting firm in Denver, BCGH Consultants. He was interviewed last Monday and this past Monday, and you can go out and you can watch that video right now. Very good introduction of augmented reality that is driven by data, as Scott will attest to. Furthermore, Scott is a moderator of an upcoming next week at this time, the National Academy's Committee on Geological and Geotechnical Engineering is hosting a session called The Role of Data in Transforming Geotechnical Engineering. So this talk today is really timely. And the talk next week, I'm looking forward to it, by Ellen Rathje and Tom Stanley. Ellen, I think, as everybody knows, at the University of Texas, geotechnical engineer. Tom is with NASA, and he's going to be talking a little bit about how NASA uses data in here. This is a free webinar. You do have to register for it. So if you're so inclined, I highly encourage you to. So like I said, Scott is going to be moderating that. So let's jump into the talk today. And I'm going to do that by giving you a little bit of a case history or a little bit of a scenario. You have just won a project and you're to be commended on it. It's a very large project. You have to assist a contractor on behalf of the owner to manage all of the QC and QA data for a large barrier wall project. You know what the specifications are in the laundry list of activities of everything that you need to compile. Everything as a contractor, including the instrumentation for the project. You have a number of people in the field who are collecting all the data. You are then managing all that information, probably putting it into Excel. You are jumbling all this information together to make the commensurate reports. And now that the project starts, after you've given all this thought, the owner decides, oh, I want more. I need more information. I need progress drawings. I need to know where the instruments are. I need other things on the instruments. And he looks to the contractor to do this, but the contractor, his job is to build the wall or the barrier. His job is not to manage the data. So that's why they hired you to be able to do this for him. And so you stumble across all this, you keep working hard, you stay up late at night, and you finally compile a whole lot of paper in 3-inch binders, but you eventually get the job done. And you did such a great job that, in fact, the owner wants you to work on the next phase. It's going to extend 2 more years. Maybe that's good news, maybe it's bad news. They want to add more instruments, and now they want alarms because they want to know within a few minutes if you start to get movement. I want to know that, and you really didn't anticipate that when you were doing the data. So you stumble again, and you finally get it all done, and then you go back to the specifications and you start compiling all those reams of data. And when you do it, you realize that you forgot some things that were done a year ago because you forgot it. It's missing. So now you have to figure out how to do this. And you quickly realize that somebody needs to manage these data. It's not the contractor. It's not their job. And so you become an expert at cut and paste in Excel. And unfortunately now for you and for the owner, the next phase of the project comes along. And in fact, you are not selected, but somebody else comes along and they're going to repeat everything that you just did on the nickel of the owner. And it quickly becomes obvious here that there's got to be a better way. So how do we handle, quote, the better way? And in my opinion, you can do that one of 2 ways. You can either take the bull by the horns and you can be very active in doing this, or you can just kind of sit back and wait for others to define your role. And that's what I call a passive. So you're now at a position in July of 2020 that you can make a decision as to what you're going to do. And as you make that decision, what you do is going to now be a changer because what you did in the past is not going to work in the future. That little scenario that I gave you is not going to work anymore. And I'm going to cite some examples of that. We are entering the world of big data. A couple of the articles in the Geostrata mention specifically big data. So we go to our 2020 data source, Wikipedia, and we find out what is big data. What are big data? And we've got a little definition down here. And the words that I want to highlight for you now is when we think of big data, traditional data processing applications are inadequate. If you had a way of solving data management in the past and you now have to project it in the future, what big data suggests is it's inadequate. Let me put it in a different way. You are used to driving, or you have been asked to drive from Georgia to California. It's a 30-hour trip, 36 hours if you don't sleep, okay? But you're asked to do it in a day, okay? I can't make a 36-hour trip in 24 hours. It's impossible. You can't manage data that is coming at you so fast that using the same technologies that you did before. You have to change. And that's what we're going to talk about today. We live in a world of data. We always have, but now we have tools that get us more data faster in different formats than we ever dreamed possible. And frankly, as geotechnical engineers, we don't know how to manage this very effectively. We do it in paper, we do it in PDF, we do it on spreadsheets. We have all kinds of different formats, but it's just not very effective. But yet, contractors and owners are demanding that, in fact, we get better data, we get it to them faster and cheaper. So what do? Okay, well, think about a little bit of what do we do with COVID? We look at the TV and the radio every night and we listen for the data updates. We want to know what is happening. We need the data to help make decisions as to what we're going to do. Somebody is doing it, but who's doing this for the geotechnical profession? So let's just take a little look at when I say that data comes at us faster than we had before. These are some specifications on a project that we work on, and many of you probably work on with the Corps of Engineers when we put in barrier walls. These are some things that the contractor has to provide. All of this information has to be provided as part of the ultimate verification. It's what I call the kitchen sink. If I can measure it, I want to get it. I want to know all of these things, and I want to know them in a timely manner. So what do we do with this? How do we manage this? In the old world, when we managed it, we put it on paper. When we were finished with the project, we put the paper in a storeroom. And maybe it was on a floppy disk somewhere. And if you saw the interview from Scott Anderson earlier this week, Scott recounted a story of, he knew he had a project data. And when he knew it was on a disk, but geez, I can't even read disks anymore. So how do you get this information? Well, we now have digital records, okay? But how do I keep track of that information? So sometimes it's in paper, sometimes it's digitally. But if I look now at what contractors want and what owners are demanding of contractors, they need documentation of conformance to specifications, but they also need as-built drawings. They need to know certifications that the concrete that is using is in fact 5,000 PSI concrete. They need to know permeability testing. They need to know verticality data. But also the contractor recognizes that I can use this information and say, which piece of equipment did I use? What's the maintenance record on it? How fast did it take to really build that panel? So they can use the same information from a management perspective, not just a compliance perspective, if they have that information. And in fact, if you look at contractors now, they realize that in this data world, they're ahead of the game. They have equipment in the cab that allows them to monitor the performance of their construction, and they use it. We also see this in intelligent compaction, where we utilize instrumentation to help us make decisions. So in this regard, the contractors are ahead of us. In this regard, they recognize the value of it. So what we recognize by doing all of this, and with this very brief introduction, is that I hope that I have at least demonstrated to you that, in fact, you can't build it just for the project. Because, number one, you're not going to get the next project if you do it. And we have to, but the other thing is geotechnical engineers, we realize that when we put a boring log in, when I do the QA on a panel, all these projects look the same. So if I solve the problem once, I can utilize that over and over again. And if I take advantage of that, the contractor is going to be in an advantageous position because he knows all the data and how to get the data for the project. So he's going to be able to work more efficiently. And the owner is going to say, this is great because I'm not playing to reinvent the wheel on every project. So if you don't do this, if we don't start recognizing this, we're going to become extinct because somebody else is going to figure it out. So the story, or what I would like to hopefully convey to you, is that we have to start changing. So at this point, I'll have a little segue and say, well, geez, Bob, this is really good. So why aren't we doing it? Well, there's any number of reasons why we don't do this, because we have to change. And changing is difficult because A, we don't like it. Okay, change is the red-haired stepchild. Nobody likes the red-haired stepchild because when you look at all of the things that you do, it is very confusing. It can be overwhelming. And at the end of the day, from a geotechnical perspective, it's just plain boring to look at data all the time. So we need to figure out ways. And what I'm going to hopefully be able to do in the next few slides is to tell you that it doesn't have to be any of these things. So before we jump into some demonstrations, I wanted, I'll kind of let you into the secret data management handshake. And this is something that I've learned over the course of the last few years, working with my colleague, Jamie Rosen and Raphael Sieberman, who are data gurus. And they said that, there are certain tenets of data management that we need to recognize. And there's not that many of them. The first off is that data resides in one location. I can have a copy of the data, but the data really lives in one place and everybody knows where it is. And you can't change it. If you want to change that information, you don't want to have to copy and paste it. You just want to be able to just go out and grab it. Run a query of the data to find out what you want to do. The data that we have does not belong to us as geotechnical engineers. It belongs to the owners. It belongs to the Corps of Engineers. It belongs to the city of Atlanta, whoever is paying the bill. So if I manage their data, I don't own the data, they do. And we need to be of the mindset that we are managing their data, but we're never holding the data hostage, and that you have to constantly be living by my rules in order to get your data. And sadly, there's some people who don't believe in this tenet. I very strongly believe in it. The other thing that we recognize is that we need the data. We're going to assign this to a location. So we need a consistent spatial format. One of the first projects that we got involved with several years ago was with the Maryland State Highway Administration. And the hardest part of the project was trying to recognize and to make consistent seven different spatial formats that were used on historic projects. So we need to have that consistency. And if we can do that, it will help. The data should be transferable, and you want that information to be documented so that people who come along and pick this up later on know exactly what we're doing. So these are rules, tenets. So if you recognize this, if you do this, this will, in fact, it doesn't sound that difficult, and it's not, but it does involve a change. So one of the things that you're going to find as we go forward here is that when we start talking about managing data, we're going to be talking about putting things on websites and doing things in data management and transferring data and putting things on GIS systems. And if you go back and you recognize what you did as a student, you weren't taught any of this stuff, okay? So professors, for those that are there, we need to start changing in our curriculum what we train people to do, because this is going to be the demand of the future. Not that it's a standalone entity, but students need to be aware of how to do things like this. So we need to recognize that at the university level. I'm going to roll all of this up into a concept that I call information management, IMS, an information management system. And I'm going to give you some examples of information management. And I call it information management because I don't want you to think of this as just managing specific data. We want to manage everything around a project. And in a complete format and in a very efficient format. So as we look at that, we start to look at the workflow of how do we get this information, how do we get this data. I think everybody is aware that we can get the data by field notes, putting them in a notepad, writing them on a little smart pad. I can get instrumentation from lab tests, from field instrumentation. So, we've got, some of the techniques that are out there with commercially available packages that you can get with, from Alan Marr, Steve Troutwine, and other people of this. We're really getting very powerful at getting this information, as well as historical documents and maps. So I think we're all familiar with the input. What we're not familiar with is what do we do with that? I got to get that somehow into a format that I can do something with and I can manage. And once I get it into there, the software vendors do wonderful things with helping us visualize it, post it back to the web, put it in layers of GIS, help us manage reports. So step number 1 and step number 3 we're good at. The missing link is step number 2, is that we don't do this very effectively yet. And this is the challenge in the future. Well, I say it's a challenge, but let's just say, well, can you show me, Bob, that it really is effective and prove that it works? One of our first activities that we got involved with on a large construction project was Wolf Creek Dam. And for this, I thank folks like Mike Sokola and Vanessa Bateman when they were at the Corps of Engineers in Nashville, and Dave Paul from Denver, that they said, we like this idea because we have this large project. We have an enormous amount of data on what was a very high hazard dam. And we had all of this information. I wanted to compile all of this. And in fact, when the end product was developed, we helped the Corps develop this, and Vanessa was the one who drove the ship when they had to make the presentation to the board. It wasn't an external consultant. The owner understood the system and was able to make this work by compiling all of this information. What I think is an even more impressive project, and I'll talk a little bit more about this one a little bit later on, was the Crossrail project in the UK. It involved construction simultaneously of 8 tunnels underneath central London over 42 miles. But the biggest challenge on this project was that there were over 10,000 instruments of various sorts that had to be read, and that data had to be available in real time, pseudo real time, because I wanted interpretations of the data in 10 minutes. How is it humanly possible to do cut and paste spreadsheets of 10,000 bits of data updating every 10 minutes? It's not possible. You have to come up with different tools. These are the world of big data, okay? So let's take a specific example of how we might utilize data like this. Say a secant pile wall that we're using for a hydraulic barrier. The contractor is very adept at being able to drill and to fill these holes. But if it's a hydraulic barrier, what I am most concerned with of this is that vertical. Vertical in both planes. How can I make sure that in fact it is vertical and that it isn't truly a cutoff? So I have all of these data and I need to know the geometry with depth, say every 2, 4, 5 feet. I need to be able to know how these are all correctly aligned. And the contractor is going to want this very quickly because if he has to re-drill it, he wants to know it right away. So we query the database at a given elevation, at a given point in here, and we just simply say at that point, what is the overlap and how does that overlap match the specifications? So we don't have to touch the data. We interpret the data and we go ahead and develop the analytical tools to grab the data to give us the information we need and to demonstrate compliance. When we first made this point to the Corps, Mike Sokola, again, my hat's off to him, is he said, you know, at the end of the day, if the project is done correctly, I compile all of these plan projections vertically, and if everything comes out to be blue, I'm great. The project is done. So we don't have to go through and look at individual records. So this is something this is the end product. Not only can we see this during construction of this, but if I look back on Wolf Creek, the reason it's a high hazard dam is because it was built on a karst terrain, and the karst is still there. So now when they go to put in the cutoff wall, before they put the cutoff wall in, they put in grout holes to slow the subsurface flow of water. Well, now we have records of that information, that data, and we can look at grout take with each penetration of our grout pipe. And knowing where the grout take is high, we now know where all the problems are. And in fact, we have a pretty good subsurface profile using the data that we got from construction. So now we get an added benefit of this. The sister dam of Wolf Creek is the Center Hill Dam. And for Center Hill, we did a similar project of looking at grout takes. But now because we have a stream downstream of this, and we're putting in grout that is high pH, if that grout gets into that stream, we're going to start killing fish. So we want to look at environmental monitoring and get early warnings, whether we have start to indicate that we might getting some creep. So now that we have these capability, we can start to see this, and now I can project a map like this. And if everything looks green, I'm in great shape. So all it takes is one picture to tell you the status. We can do that if we manage the data effectively. We can also do that for landslides. This is a large landslide in Pittsburgh, where we looked at the data of how was the landslide performing when we started to lower the water table. And could we effectively reduce this with pumps? And are the pumps or are the water levels related to rainfall? Again, a lot of data, but if you collect the data and you have these maps that are updated periodically and automatically, it helps us do our job better. And the last little example I want to talk about is a project one of my colleagues, Lucas DeMello, David Espinoza, worked on the Cherry Island landfill, where we built a wall built a reinforced soil slope to expand the landfill, but it was built on very compressible materials, adjacent water. And the last thing we want to do is we want to have a failure. So we have to use that fill to consolidate the subsurface materials. And so we use the feedback from the instrumentation to measure pore pressures, to measure the inclinometer movements in areas that we know that we're going to get feet of settlement. And we don't want that to happen. So we make predictions in finite element as to what we think the excess pore pressures will be. And then we monitor those. And at each step, we can evaluate the factor of safety. So we use the data to go back and to evaluate when we make decisions in the field. So, I mean, you can see that we have that. I do want to come back to the Crossrail project very briefly. And I want to talk about this from an overall project perspective, because again, we're trying to monitor the construction of the tunnels, but this tunnel, this is 43 miles of these tunnels are going all across London in various directions, and some of those are going underneath a very densely populated area. And we know that in these areas, we don't want buildings to move, streets to subside, etc. So we want positive feedback. But everybody who's working on the project, all of them have a slightly different need. Some of these may want information just about the overall system from an alarm perspective. They want to see what's happening in various buildings, and they might want to drill down. So knowing that the data are there what we can do is you query the data to develop individual maps mapped to individual stakeholders. Some of them might want to look at just the alarm level system-wide. And so we develop a screen specifically for that. If you're the project manager of one of the 43 stations, of one of the 36 stations, what you do with that is you are very interested in what is going on with the instruments in and around your station. And you might want to know where it is and how it changes over time. And so you map all of this to a GIS system that is updated for your use. And then you may use kriging or other analytical tools to help interpret that data. And you want that plotted, and you can augment all of this. So once we have the data, we can do wonders with this. We can project it onto buildings. We can show where these are. We can convince the public of where we are. We talk to the contractor. The contractor sees this. They can start making adjustments to the drilling techniques, the face pressures, etc., in advance of seeing movements in the field. So we can start to now get this. So hopefully, again, I've told you, and I'll say this, one more drink of Kool-Aid, that, hopefully you're nodding your head and you say, okay, I can kind of see where this is, but, I don't like people telling me. I don't like you, Bob, sitting there and telling me what I have to do. I'm a smart geotechnical engineer. Well, you know what? You can be a smart geotechnical engineer, but if you work on the web and you want to check into a hotel, you have to tell them what nights you're going to stay. And in this particular case, if I'm going to stay at the Embassy Suites, they want the date in this format. But if I have to get to the hotel, if I read that format into the Delta webpage, it says, no, I don't know what that date is. I need you to put it in a certain format. And so you do. If the format is there, you do it. All right? So we live in a world of data. And in fact, we live in a world of standardized data. We live in it, but we don't live it in geotechnical engineering. Okay? So this was really driven home in this little schematic. I borrowed this several years ago from Roger Chandler at Kinetics, now of Bentley. And in fact, the schematic similar to this is in Scott Deaton's paper in the Geostrata, where it says, if I'm the engineer and I've got a big project for the client, I can bill a gazillion hours because I'm going to get data off of the region. I'm going to report data back to the client. I'm going to get data from various labs, and I'm going to get multiple drill crews, and they're all going to give me data in different formats. And I'm going to have somebody sit there and regurgitate all that information and put it into a format that I want. And I can bill a lot of hours to do that. It would make a whole lot more sense if we could figure out a way to do this. Well, let's escalate this a little bit. And let's say that I am a web server. I'm Apache. And I know that there are 4, and now there could be as many as 30 different web browsers, but the 4 biggies, Firefox, Chrome, IE, and if you work on a Safari with Mac. So if I'm Apache, I say, well, every web browser that comes in, all we've done here is we've said that if I'm Apache or if I'm Chrome, I have to develop 2 different systems, depending on which servers are used. And if I'm Apache, I have to develop 4 different systems. And the internet said, this is crazy. We're not going to do this. We're not going to put this. We're going to develop a standard data transfer format called HTML. Okay? You use HTML every day and you don't even know it because that's the only way that you communicate between browsers and servers. Okay? And what HTML is a standard. Standard, that's the key. It's a standard way that everybody knows the rules as to how we transfer the data. We do it with a series of tags. And a similar code, a code similar to that, is what's written down in here. Okay, so here is the code, and I don't know if that pencil or that marker is in there, but Oops, if I go back to here, there we go. Hopefully it's there. That this is the code. There's the data. So if I take that data and I am a software vendor, I take the data and I say, oh, here's what I want to do with that. So I read that markup language, and as a software person, I present it this way. Well, that kind of looks plain brown vanilla. So I'm another software vendor who has a little more ingenuity in here. And so I take the same exact format, the same data, and I present it differently. I don't change the data, I use the data differently, okay? So this is what we get when we see all of these things on the internet. And this is what we could do with geotechnical data. So you'd say, well, okay, I see where this is going, Bob. You're going to tell me I have to understand HTML in order to do this. Well, maybe, but let me ask the question. As long as you get up in the morning and you click on and you do Google, do you even care what HTML is? As long as it's working? And did you need to know HTML to use the internet? And the answer was no. Because if you become a user of this standard, and as long as you play by the rules and you can effectively develop this, then in fact, the world is at your fingertips. So we have something like that. In the US, we have it. It's been around for a few years. It's called DIGS. And I'm not necessarily going to advocate for DIGS, although I will very happily advocate for DIGS. But the point is that DIGS is what we call a data transfer standard. DIGS is an acronym for Data Interchange for Geologic, Geotechnical, and Geoenvironmental Specialists. And what this means is, going back to Roger Chandler's image, is that rather than to have 14 different formats, if everybody played by the same set of rules, you could exchange data between consultants, to owners, to contractors, and between software, simply by everybody playing by the same set of rules, the standard rules. So what DIGS is a standard geotechnical data interchange. And you'll notice in this image that DIGS is not the database. Everybody has a database. All the state agencies, the federal agencies, they have their own database. We can't start providing databases to them and telling them what kind of database they need to use. What we need to do is tell them the format of the data to store on their database so it can be effectively interchanged between this. That's what DIGS does. DIGS or any other type of a pseudo-standard format. And once you get that, now we're back to that third box where the software vendors can develop boring logs. They can put this in interfaces. We can develop reports from labs, from field instrumentation, effectively automatically by querying the database. So software people will help us at the end if we will adopt a format that they can rely on. So that becomes a challenge. So my hat's off to the DIGS committee. It started with a pooled funds study several years ago from Federal Highway Administration. This program, DIGS, is now being housed at the Geo-Institute in collaboration. There's several DOTs around the country. The Ohio DOT is the lead agency in completing the pooled fund study, and it's now available. And the committee that did this, again, I will do a shout out to Alan Cadden of Schnabel Engineering. He is the liaison between the DIGS committee and the Geo-Institute. But several members on the committee have participated in this, and I think they have done a fantastic job in terms of getting us to where we are today. But for the DIGS committee, we didn't start with a clean sheet of paper. And in fact, if you look, you individually, if you look around the country, you look around the world as to what do other professions and other geotechnical people do. 1991, almost 30 years ago, a group of geoengineers in the UK developed what was called the AGS system. The Association of Geotechnical and Geoenvironmental Specialists, AGS, is the equivalent of the GI. They started to develop this, and in fact, it's working today. 30 years later, they have a working model of this, and it works quite effectively. It is now required. A standard format is required on most large projects in the UK. After the 2011 earthquake in Christchurch, the government of New Zealand said that we have to rebuild large parts of Christchurch. And because all the geotechnical data is now worthless, effectively, because everything liquefied. So they developed what was originally called the Auckland or Canterbury Geotechnical Database. Now it's called the New Zealand Geotechnical Database. You can log into it and you can see it. But right now there's 23,000 CPTs, 10,000 borings, and 6,000 lab tests that you can access from here. Scott Anderson mentioned the other day that in fact in Singapore, they do the same thing. So parts of the UK, New Zealand, Singapore, certain countries now are doing this. They have done it. So we're not inventing anything here. We're just trying to say to use that. Other industries do this. The pipeline that pumps fracked gas, that pumps crude oil across the country, many of those developers, they put them in a common pipeline. They have a common problem. They want to know the pipeline condition. And so there's an organization that has developed standards for how they manage, inspect, and maintain the pipelines around the country. And there's a standard format for that members subscribe to. And thanks to Lauren Turner at Caltrans and his other colleagues at Cosmos, we actually have a geotechnical virtual data center. It was developed as part of the Cosmos initiative now almost 12 years ago, but it's not used because people say, I don't really want to do that. It's inconvenient for me to do it. And, you know, if you want me to use it, you want to charge me for it. And I'd rather go ahead and do cut and paste. So it's there, it can work, but if it's not adapted, you know, it just sits there. It's wasted effort. And I don't think it should be wasted. So I want to wrap up here with some philosophical observations and some thoughts for you to take away from the presentation today. The first thought I want to leave you with goes back to a movie, and I'm probably dating myself. Kevin Costner, in a movie called The Field of Dreams, said that, you know, if you build a softball field or a baseball field out in the middle of nowhere, if you build it, all of these legendary baseball people will come and play. And from that, you probably remember the adage, if you build it, they will come. Okay, I want to take a slight spin on that because the AGS, the New Zealand database, digs. It's built. So the question is, if you build it, will they come? What is keeping people from doing this? Other than it being the redheaded stepchild, bewildering, boring, etc. Okay? So somebody needs to step up and say, I want this, and I'm going to demand it. The owners could do this. Federal Highway Administration could do it. AASHTO could do it. And in fact, AASHTO is very close to saying, thou shalt. So hopefully they will come because the tools have been developed. Again, you can wait for it. You can be passive and wait for it, or you can say, this is a better thing to do. I have to start changing my practice to get there. Okay? The other philosophical point is it's going to require change. As I said, we're going to have to learn new things at the university level. Okay, and change is always uncomfortable. You know, some things are good for you, but they taste bad. Okay, we recognize that medicine, that doctors give us things that don't always taste good, but we need to do it to get better. So from a philosophical perspective, I really encourage you to embrace change from that perspective. And I can probably, even though I can't see the snapshot of your faces, I can probably guess at what you're saying. You know, I don't have enough time for this. It's really, this is not the way we do things. I have to now convince my management that change is good. I'm not worried. I'm really worried about the security of my data. So therefore, I'm not going to do anything that's going to cost too much money. And you can probably add about 3 or 4 more bullets. But before you put this in as one of your questions about change, I want you to think about something. When I was in school, we didn't have handheld calculators. We did things by a slide rule. And for the younger people here, that's what a slide rule is. Okay? And we did a lot of things by slide rules. You know, we did engineering stuff. And if you remember the movie Hidden Figures, Katherine Johnson, who just passed away, was one of those human computers. And not only did Katherine Johnson figure out the calculations to get John Glenn to be able to circulate, to make it around the world, okay, and to safely come in at the right angle so that he didn't burn up, okay. We put somebody on the moon in 1969 without a computer. Calculations were done with the slide rule. So, you're NASA, you're doing this, and somebody comes along and says, put a computer in. And you say, no, I don't want to do that. Well, we'd never consider going back because we recognize that sometimes change is inevitable, and in some cases, change is good. It just needs to be up to us to be able to see that. And the last slide I wanted to do to kind of tell that story, I kind of stumbled across this, but when I looked at it, it really drove a point home to me. And I call it the evolution of 34 years. In 1943, Tom Watson was the president of IBM. And he made this statement in 1943. IBM made computers. I think there is a world market for 5 computers. 5. And IBM is going to make all 5 of them. 34 years after this, 2 guys sitting in a Palo Alto apartment said, hey, what about a personal computer? Forget all that IBM stuff. What about a personal computer? So Steve Jobs and Steve Wozniak got the idea of the Apple computer. 34 years after Watson made his statement. 34 years after the founding of Apple, Steve Jobs passed away. There's a 68-year time span that has in fact revolutionized and completely changed how we as a society do things. So what would happen if they didn't make the change? What if somebody said, it's going to change my culture? What if it's too expensive? Think about where you'd be today. We have to be ready to embrace change. And certainly data and data management is one of those changes. So as I wrap this up, go back to the title. What do we do? Do you do it reactively and wait? Or do you be proactive? So hopefully over the last hour, I hope that I didn't sound like a used car salesman, and I'm selling you a bill of goods. That's not my intent. I also don't want to be considered a crusader, because you remember those guys died. People killed them, okay? But hopefully you look back at this and you look back at your practice and say that when I look at geostrata, I look at this presentation, and I look at the practice, that we are on the brink of being prophetic. We have the ability to change how we do things, and the change will be for the better. So for all the students out there, welcome to a very prestigious organization, and thanks to everybody for taking the time this afternoon to participate in this. Stay healthy as over the next several months while we adapt to this, and don't forget the upcoming Read Geostrata. Go back and look at Scott's interview. It's posted on YouTube. Geostrata you can read online, and then you've got this next week. So Jeremy, I will turn it back to you if there's any questions. And again, I really appreciate everybody sitting through this.
Excellent talk, Bob. Thank you very much. And we do have some questions coming in on YouTube, and also one from our Instagram account. We'll start with that one. How important are machine learning tools in geotechnical data management?
Well, great question, because as you see in the Geostrata little thing here, the subtitle is Machine Learning, Big Data, Artificial Intelligence, and Visualization. You don't get machine learning unless they have the ability to mine data. So you've got to have this. And in fact, you have to, there's a whole world out there about machine learning. You can read in a profile and you can tell the machine how to interpret a geologic profile. The more data you have, the better the profile will be. But the machine is going to come up with a lesson. So as we look at artificial intelligence and machine learning, we want to make sure that, in fact, we understand how those algorithms are written. But we absolutely need that data for that.
All right. How do you see the potential of building information modeling in geotechnics?
Great question. Building information modeling, BIM, is now becoming it is a standard. And in fact, the software in the UK in BIMs has incorporated the AGS system, and in fact now includes subsurface information as part of BIM modeling, so that we can see the subsurface in that same model. So, it's going to be a component of it. Obviously, it's the subsurface, and I think as most people recognize that in a large construction project, most of the time, or a large part of the time, is spent underground. And using that information, once we get above ground, we kind of go into autopilot. So I think that it will definitely has a role in that in that framework.
All right. We had a couple comments come in, or questions come in, just talking about the challenge of getting agencies, DOTs, and federal agencies to require data transfer through digs. And I know you talked about it a little bit, but I don't know if you had any other comments on.
Again, I appreciate the question. If you were in Alabama working with Kay Chancellor, if you're in Ohio DOT and you're working with Chris Merkin up there, you don't have a choice anymore, because they are going to require you to give them a digs format if you want to get a contract with them. So several DOTs have adopted this. As I mentioned earlier, AASHTO, it did go out for ballot, and now it is, I forget the exact terminology, but effectively it's provisional that it can be required. And there will be after going through some the learning curve, there will be an AASHTO standard developed for this, and AASHTO can simply say, if you want to work on a federal aid project, you have to give me the data in here. The key to doing this is for owners to, in fact, insist on it. And one of the ideas of the DIGS committee has been, in fact, to try and talk to those owners and get them to be able to do it. Because, I think Voluntarily, it's probably not going to happen, even though it's a better way. That castor oil is a little bit difficult to swallow all by itself. We need a little bit of a kick in the pants. And I might point out on that same notion, Singapore and New Zealand, talking to the folks in New Zealand, the New Zealand government has a line item of about the equivalent of about $1 million a day, $1 million a year, I'm sorry, $1 million a year to support the development of a standardized New Zealand geotechnical database. So if the government sees it, then it can again be required, and it is going to take some effort, obviously, to do this at a national scale. But this does not mean that, in fact, you do a boring and it becomes available to absolutely everybody. That's not the real goal of this. The goal is, we would like to have it to be like they do in New Zealand, but what it is going to do is it's going to allow you to more effectively communicate on project level information, and to get into with software vendors that they're going to be able to do things more efficiently because they don't develop standard, customized formats for every different application.
All right. What role do you, oh, sorry, I just lost it. What role do you think will data analytics, for example, Bayesian updating with data, will play in the near future?
In the near future, okay, I think this one is kind of related to the previous question, and that is, where is this going to go? If in fact, well, let me take that back. I see maybe even a shortcut. If I'm the Corps of Engineers, for example, and I'm managing projects along the Mississippi River Valley, and if I've got all these districts on the Mississippi River Valley, somebody could be sitting there and looking. Those data don't necessarily see district boundaries. The subsurface doesn't see it. So as you get more and more data, as you get in there, the machine can in fact learn how to in fact incorporate that, change that information, and come back with a different interpretation. So again, I want to draw to the perspective that you have the data. The data, as Scott Anderson said, the data are the facts. There's no doubt about that. But also then when you start doing Bayesian updates and things along that from statistical perspective, we're doing interpretations. And there's always going to be a role for geotechnical engineers, for engineers to be able to evaluate that data. But if the computer can say, hey, based on this information, here's a first cut at it, I think that it will end up being very, very helpful. Okay.
Are there any similar initiatives in other areas of civil engineering, outside geotechnical, for say in structural or water resources?
I have seen some work of this in water in structures. The water resources, when you do a flood map, when you predict the 24-hour, 100-year flood, that's based on statistics looking at real data, and they update those models. So the hydraulics has been all about data and incorporating the data from that perspective. So there's definitely work in there. The transportation community has seen it, and as I mentioned, the pipeline, the ASCE pipeline. They have a whole other, discipline relative to that. And so all of those pipeline people are aware, most of them I think are aware of pods and what it is. So I think there's a lot of work going on and people are recognizing this. And Brad may want to weigh in on the familiarity of or his familiarity with what other institutes might be doing relative to that.
All right. We had a couple questions on this, and I have a personal question on it. it's one thing to build a database for a new project where you do new construction and you're putting in all sorts of new instruments. But I know you and I both work on a lot of hydropower dams that are 100 years plus. There's a lot of old data in there. Would you mind speaking about how you might, like, how you go when you're approaching a new time on an old project? How you go about compiling a database with many different years of data and getting it all into one file type?
That's a really good question, Jeremy, and it's a very common question, and I want to answer it in a couple of ways. Number one, it is probably one of the most common anti-database questions that we get, because people say, if I look at all of my files, it would take 15 years in order to get that read into the file. And say, okay, well then, next year you do it, it's going to be 16 years. Okay, so number one, you got to start somewhere. But more importantly, going back to your point, if in fact you have a historic dam and you have information and you are the consultant that is working on that dam, once you get the assignment, what's the first thing that you do if you are a geotechnical engineer working on a historic project? You try and find all the data and you try and interpret it. That's the time to go to the effort of putting it into the database. And once it's in there, it's now there for good. And if you question the data because it wasn't with an energy calibrated SPT hammer, because it predated that, you can make a note of that. You can put a flag, you can put red, yellow, green in terms of their reliability. If in fact you think it's just dead wrong, you can just say, I'm going to eliminate it from being considered on this project because it's the wrong stationing, it's the wrong location here. So the point, I think, is that you do it on an as-needed basis. And if you do it on an as-needed basis, you can in fact efficiently do that, because it's something that you should be doing anyway if you're going to get one of those historic projects.
All right. Just a few more, but before we keep going with the questions, Bob, would you mind stop sharing your presentation? We'll go out on the videos.
Okay, let's see. So I go into here and I say,
that's it. And I have a philosophical question. You talked about a lot about students learning data management in class. And what if somebody's in an era of specialization? What if somebody says, well, I'm going to specialize in geotechnical engineering and let someone else specialize in data management? Could you speak to maybe the danger of having, obviously it's important that engineers control their data, but, is there a danger of being, separating those two things? Should we keep them together? Can we split them up? What's the overlay between geotechnical engineering and the data management in a philosophical nature?
Yeah, good question, Jeremy. And I think, again, my perspective on that is, several years ago, we were called there were geotechnical engineers and there were environmental engineers, and we didn't talk to each other. And now we have geo-environmental or hydro-geo. I think that, we recognize that we're in a world where there is a lot of collaboration. And particularly with tools like this, I mentioned a couple of colleagues of mine. I'm going to pick on one specifically, Jamie Rosen. Jamie's a hydrogeologist, but he now is he is driven by data. So I think that the driver is going to be that we need to interface. We need these specialists. We have folks in our firm, and I'm sure other people do, where we have GIS specialists. Well, we need to collaborate with them. We don't want to take their job, and I don't want to take a geotechnical engineer and train them in GIS, because that's a rapidly developing field. So I think that the idea is really one of collaboration, and so that we don't want that those people to in fact be driving our business. Just on a separate kind of course subject, but my father worked for Shell Oil Company for many years, and all of his life, in fact. And in fact, in the mid 1970s, what he said was that the managers came in and they started running the business, and we became a different company. Shell Oil became a different company when the managers ran the business, because the managers didn't care what was happening at the grassroots. I think to go to your question, it's really, we want to avoid that. We don't want the GIS people, we don't want the artificial intelligence people to tell us what the geologic model is. We want to help and collaborate with them so that it's a win-win for everybody. And my experience is that when we reach out and collaborate with those people, that in fact they like it. It expands their window and they can see how people are using their work products.
Excellent. Thank you. I believe that's all the questions for today. Brad, I'll give it back to you for some closing comments.
And this time we'll have the volume on, so maybe everybody can hear me. It was a very, very intricate technical issue before. Just again, for more information on the Geo-Institute, if you're not a member, check out our website. The link is down in the description. If you like these YouTube videos, this is going to be archived to the YouTube channel, so you can watch it forever and ever. The presentation that Bob mentioned a few times, Scott Anderson's from Monday, it's called GeoStrata Extra, and you can watch that on our channel as well. Click the little bell up there if you want to subscribe, get notifications from the site. Tell your friends about this if you liked it. We'll be doing more of these streams in the future. I think this is what we're going to be doing for a while. So I hope you enjoyed it. Thanks to Jeremy. Thanks to Bob. Monday is our next stream. It's going to be on teaching during and after the pandemic. So come right back here at 2 p.m. and we have a panel discussion. We're doing that jointly with USugar. And I think it's going to be another great discussion. So thanks again, everybody, and we hope to see you on Monday.
Thank you, Brad.